Hi, my name is Kate, coming to you from Lima, Peru, where I'm a high school physics teacher. This week's theme is organization, so I wanted to tell you about one of my favorite organization schemes in physics. I want you to think of the smallest thing that you know of, the building blocks of matter itself. Maybe you're thinking of elements on the periodic table. Perhaps you have the image of an atom in your mind. Or maybe you even thought of the protons and neutrons inside of the nucleus of an atom. Well, what if I told you there were things even smaller? So I want to introduce you to the subatomic world, the world even smaller than atoms itself. It's a world with funny named particles like the charm quark and the neutrino. And they're all running around bumping into each other. It's a world of chaos that can be organized using what we call the Standard Model.
So let's take a closer look at the Standard Model. On the left, we're going to put fermions. Fermions are all of the particles that make up the stuff we can see in our everyday lives. And on the right side, we're going to put bosons, sometimes also called force carriers. These are particles that we think are responsible for the forces in our everyday lives. Let's focus in on fermions. Now, there are two types of fermions, quarks and leptons. Now, the quarks come in different, what we call flavors, kind of like ice cream flavors, except these flavors have very funny names. There's the up quark and its counterpart, the down quark. Next up are the charm quark and the strange quark, followed by the top quark and the bottom quark. I guess I should mention that all of these particles also have antimatter particles. They are exactly the opposite in every possible way. To our knowledge, these quarks are never found alone. They combine to create what we call hadrons, and hadrons could mean baryons or mesons. You've probably heard of a couple of baryons. Neutrons and protons are examples of baryons. Let's take a look at leptons now, or other type of fermion. We have electrons, muons, and taus. And for each of those, there's a corresponding neutrino, the electron neutrino, the muon neutrino, and the tau neutrino. Let's now shift our focus to the right side of the paper, so we can look at bosons, also known as force carriers. Bosons are split into two categories as well. The first category is gauge bosons. In this category is the gluon, the photon, a Z boson, and a W boson. And then in a category all its own is the Higgs boson. Now, the Higgs boson is super special because we think that it gives all the other particles mass. In 2012, scientists were able to detect the Higgs boson for the very first time.
So as you can see, even the smallest things that we know of in our universe can be organized into categories so we can better understand these similarities and differences.
There are lots of different ways of drawing the Standard Model, different ways of organizing our knowledge. This one, for example, kind of reminds me of the periodic table a bit. This one is organized in a slightly different way, using circles and then dividing them up. On the top are the quarks, on the bottom are the leptons, and then the gauge bosons on the inside. And my favorite part of this is that the Higgs boson is right in the middle. But no matter how you choose to draw it, the organization of the Standard Model continues to blow my mind.
That's all for this week. Stay safe, and I'll see you next week on Outside the Classroom.